Assalamu alaikum. We'll continue our online lessons with Chapter 2, Lipids. At the end of this lesson, you will be able to define lipids, list the functions of lipids in the human body, define fatty acids, define saturated and unsaturated fatty acids, define triglycerides, phospholipids, and cholesterol, and distinguish between fats and oils. But before to start, please you have to prepare your pencils, papers, and your chemistry books.
Olive oil is 100% fat. There's nothing else in it. Pancake mix, on the other hand, is only about 11% fat. And yet, olive oil is good for you, and pancake mix is not. Why is that? As it turns out, the amount of fat we eat doesn't impact our weight or our cholesterol or our risk of heart disease nearly as much as what kind of fat we eat. But let's back up. What is fat?
So what is fat? Fats or lipids are a class of natural compounds that include triglycerides, fats and oils, waxes, phospholipids, and steroids. Most of these compounds are esters of fatty acids and alcohol. Lipids are insoluble in water but soluble in organic compounds. Lipids in food can be identified by the formation of a translucent spot on a paper. Lipids have an important role in the human body. This role depends on the type of lipid. Fats and oils, triglycerides, are the major form of energy storage in the body. Steroids and phospholipids constitute the main component of the cell membranes. And cholesterol plays a role in chemical synthesis within the human body. It's the starting material for the synthesis of many hormones and vitamin D. As we have said that lipids are esters of fatty acids and alcohol. But what are fatty acids? They are carboxylic acids with a long chain of hydrocarbon made from 4 to 36 carbon atoms. They are classified as saturated fatty acids and unsaturated fatty acids. They differ from each other by the number of carbon atoms and the type of bond between carbon atoms. If all bonds between carbon atoms are single covalent bonds, we say that the fatty acid is saturated as butyric acid in the figure. If it contains at least one double covalent bond, it's then named unsaturated, as you can see in the figure. If it has one double covalent bond, the acid is called monounsaturated, mono from the word one, as you can see for the oleic acid. If it has more than one double covalent bond, it's then called polyunsaturated, as you can see for linoleic acid that contains two double covalent bonds. It's considered as polyunsaturated. So how does this affect the properties of fatty acids? The physical properties of fatty acids are determined by the length of the hydrocarbon chain, means number of carbon atoms in the chain, and by the degree of unsaturation, means number of double covalent bonds in a chain. Example, saturated fatty acids containing 12 to 24 carbon atoms are solid at room temperature, while unsaturated fatty acids of the same length are liquid at room temperature. Since the length of the hydrocarbon chain and the degree of unsaturation means the number of double covalent bonds are important to give the properties to a fatty acid, we represent each acid by these two properties in the form of two numbers, where X represents the number of carbon atoms in the chain and Y represents the number of double covalent bonds in the hydrocarbon chain. Example, palmitic acid. If we count the carbon atoms, we find that they are equal to 16, and there are no double covalent bonds between the carbon atoms. So we can represent this acid by 16, 0, where 16 represents the number of carbon atoms in the chain and 0 is the number of double covalent bonds. Now in the opposite way, if we are given the representation of linoleic acid as 18, 2, we know that there are 18 carbon atoms in the chain with two double covalent bonds as shown in this figure. We have seen the classification of fatty acids Now let's move into the classification of lipids. Lipids are classified into simple lipids as triglyceride and complex lipid as phospholipid. Simple lipids are esters of fatty acids and alcohols that contain carbon, hydrogen, and oxygen in their molecule. Glycerides are esters of fatty acids and glycerol. Triglycerides is the most abundant natural simple lipid. They are hydrophobic, means they are insoluble in water. Hydrophobic, hydro from the word water, phobic from the word fear. So how are triglycerides formed?
Triglycerides contain two types of subunit molecules, glycerol and fatty acids. Remember, a fatty acid is only a small part of a triglyceride. To become a triglyceride, 3 separate fatty acids have to bond with a glycerol molecule through the process of dehydration synthesis. Triglycerides include the fats and oils. Fats, such as lard and butter, are solid at room temperature and are used by animals for insulation, protection, and long-term energy storage. Oils, such as corn oil and olive oil, are liquid at room temperature and are used by plants for long-term energy storage.
So, triglycerides are formed when one molecule of glycerol reacts with 3 molecules of fatty acids and 3 molecules of water are released. The melting point of triglycerides depends on both the length of the hydrocarbon chain and the degree of unsaturation. Melting point decreases with the increase in the degree of unsaturation and in the length of the hydrocarbon chain. Don't forget that degree of unsaturation means number of double covalent bonds. Now, we move into complex lipids. They have the same structure as simple lipids, except that one of the fatty acid residues is replaced with other groups, such as groups containing nitrogen, phosphorus, sulfur, and sugar. Example: phospholipids are complex lipids that contain in their structure a phosphoric acid residue. Glycolipids and lipoproteins are also examples of complex proteins.
Phospholipids are similar to triglycerides in that they contain glycerol and 2 fatty acids. What's different is that a phosphate group rather than a third fatty acid is attached to the third carbon of glycerol. Phospholipids are extremely important, mainly because of their unique properties in regard to water. The phosphate head of the molecule is hydrophilic, or water-loving. This means that it mixes well with water. The fatty acid tails, however, are hydrophobic, or water-hating, and do not mix well with water. Because of these unique properties, phospholipids tend to arrange themselves so that only the hydrophilic heads interact with the watery environment, and the hydrophobic tails crowd inward away from the water. This structure is the major component of plasma membranes of the cell.
Now, the third category of lipids is the steroids, which are lipids with structures based on the steroid structure. Example: cholesterol, which is the most abundant steroid in the human body. It's not found in plants. Now, thank you for your listening. You have to read your book, pages 28, 29, 30, 33, and memorize summary sheet number 8.